Hi, this is the Year 8 periodic table homework. It's kind of like essential knowledge you need. So you need it for Year 8 and you also need it to help you with Key Stage 4 chemistry. Right, so firstly you've got the periodic table. Now what you'll do in your exam, you'll get a black and white version of this, an AQA1. Right, but what I've got here is I've got a coloured one that kind of shows you the different groups that are important. Okay, so alkali metals is group 1. Okay, so what I could do is I could put a 1 at the top, right? And what they are, lithium, sodium, potassium, they're the three that you kind of need to know about. We've also got the orange bit here, which is the transition metals. Okay, so going all the way from scandium, all the way over to zinc, they are the transition metals. We've got the halogens, which is then this group here, right? And that is then spelled halogen. And then the red group right at the very end there is the noble gases, and they are very, very inert. Other little facts about this is when you go across, that is called a period. So each one of these things where it goes across is a period, and a column is then called a group. Now, one of the big questions that comes up on GCSE, and it's also in Year 8, is why do group 1 metals increase in reactivity down the group? Because basically lithium, if you put it in water, it fizzes. Potassium, if you put it in water, it catches fire and can sometimes explode. But the question then is, why? Okay, so what you've got in the centre of lithium, you've got a positive in the middle, and you've got a positive in the sodium and a positive in the potassium. Okay, that looks like a -1, but it's a positive. Now, the reason why potassium is more reactive is as you go down the group, the electron in the outer shell, so that electron, and that electron is easier to lose. So what you've got to do now, you've got to think about summarising it. So the first statement you'll do is you'll say the electron in the outer shell of potassium is easier to lose than the outer electron in lithium. Then it's 3 reasons why. Reason number 1 is the distance from the positive centre to the outer electron. The bigger it is, the easier it is to lose that electron. Third one, there is more shielding. So what you've got between the positive centre and the negative electron on potassium, there is a greater amount of shielding. There's more of the other electrons in the way. And the fourth one is there's less attraction. So if you've got a positive centre and a negative electron on the outside, the attraction between the positive and the negative is less the bigger it is. So what you need to do now, you need to pause it, and then you need to go through and you need to kind of talk yourself through and understand the reason why potassium is more reactive than lithium. Because also don't forget, you might also get asked, why is lithium less reactive than potassium? It also works with group 7 elements. So what I've got is we've got fluorine and chlorine. Now, what fluorine wants to do is it wants to gain an electron there because it needs 8 in its outer shell. Chlorine wants to gain one there because it also needs 8 in its outer shell. So as you go down the group, it's actually harder to gain an electron. So fluorine, chlorine, could have had bromine here, okay, but we don't need to be able to draw bromine. That's even less reactive again. It's based on the same things that we talked about with group 1. It's about the distance. Okay, so fluorine can get that electron in easier because it's closer to the positive centre. Because the closer it is, the more likely the negative is going to want to get in. The other one is then shielding. So fluorine can gain that electron better because there's less shielding between the positive and the new electron that's going in, where chlorine has got more shielding, which is the black dots, between the positive centre and the electron going in. And the fourth one is there's less attraction. Okay, so there's less attraction for bromine in the centre, chlorine rather, in the centre, than there is for fluorine. So again, what you need to do is you need to pause it and then think about why is it harder to gain as you go further down? Okay, or even why is it easier for fluorine to gain? And it's all to do with the distance, the shielding, and the attraction. Final group that you might get talked about is group 0, noble gases, helium, neon, argon. They all have a full outer shell. So therefore, if they've got a full outer shell, they don't want to gain an electron, they don't want to lose an electron, so therefore they are inert, they are very stable. Right, so that is then key facts of information about the periodic table that you need in year 8, and then you're definitely going to need it in year 10 and 11 when you get to your GCSEs. So go back and test yourself on it.